This is 1C.5. This is the quadratic formula working with the discriminant. The solutions to a quadratic equation written in standard form, so ax squared plus bx plus c, can be found by using the quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. This formula is particularly useful when a quadratic equation cannot be solved by factoring. Okay, you might even say when it can't be solved by completing the square. So we come down here to our first example. Now when we are working in standard form, we'll want to have all the numbers on the same side. So our a term is 1, our b term is 7, and our c value is negative 6. So we're going to plug this into our quadratic formula, negative b plus or minus b squared minus 4ac all over 2 times a. Now we want to be sure to show this quadratic formula with our variables plugged in. In your work, in your homework, on your test and quizzes, you need to show this step. Now when you start to simplify the step, we've got a few choices. We've got 7 squared, which is 49, a negative 4, and a negative 6 gives us a positive 24. Now if you were to use a calculator, you could just type in and figure out that that was 73. The square root of 73. And you wouldn't have to show this intermediate step if you used a calculator. But otherwise, 49 plus 24, 60 and 13, so 73. So that is called your exact answer. Now with your exact answer, you've got 2 different answers that can happen from it. You've got your negative 7 plus your square root of 73. That's the numerator. You want to figure out what that term is and then divide it by 2. So we get 0.77. So this is approximately 0.77. That's if we use the positive square root of 73. But what if we used negative 7 minus the square root of 73? Remember that that is the numerator. That's a complete numerator, so we hit enter. And that can be divided by 2. So we get negative 7.77. So we get 2 different answers. When the discriminant, which is the part that is inside the square root, when the discriminant b squared minus 4ac, when that is greater than 0, you're going to get 2 real solutions. You're going to get the quadratic, the parabola, to touch the x-axis in 2 different spots. You get 2 x-intercepts. That is if the discriminant was a positive number. We have 2 real solutions. In our next one, you can divide by 2 to all the terms, but often we just take the a, b, and c as they are. So we want to figure out where this crosses the x-axis. So we have negative b, b is a negative 8, so you have to use parentheses, plus or minus b squared minus 4ac all over 2a. Well, you need to show that step. Plug all your numbers into the quadratic formula. Then you can simplify it. So we get 64 minus 8 times 8, which is 64. So this becomes 8 plus or minus the square root of 0 over 2. So this is 8 over 2, which is known as 4. So here, notice we have one real solution. When the discriminant is 0, when you're adding and subtracting nothing, so it's just 8 plus or minus nothing divided by 2, that gives you one answer. So when the discriminant, b squared minus 4ac, equals 0, you get one x-intercept, one solution, 1, 0 for the function. We have one real solution. And over to our last example from this group, where I would suggest to get all your terms on the same side of the equal sign. I like to have x squared be positive, so I'm going to add the x squared to the right side of the equal sign. Now this is not factorable. You can't factor this. Nothing multiplies to be 5 and adds to be negative 2. So it's going to be important that we figure out our a term, our b term, and our c term. And we can solve negative b. Notice that it's a minus, so we have to use parentheses, plus or minus the square root of b squared minus 4ac all over 2a. So simplify that. Remember, you have to write it with all the terms in there. You got to use the correct parentheses. 2 plus or minus the square root of 4 minus 20 all over 2. So that is 2 plus or minus negative 16 all over 2. Well, 2 plus or minus the square root of negative 1 times 16. And when you're times 16, that means that you can take the square root of 16, which is 4. The negative is an I, and that's over 2. It's important that if this is an imaginary number, that we break it down into the real numbers with a common denominator and with the imaginary numbers with that common denominator. And you could see that this is reducible. So we get 1 plus or minus 2i. So let's look back at what was inside as a discriminant. The discriminant was negative 16. b squared minus 4ac gave us a negative answer. When we got the negative answer, we ended up getting the I, which means 2 imaginary solutions. So looking on our notes below, so our b squared minus 4ac was less than 0. it gave us two imaginary solutions. That means the graph did not cross the x-axis. There were no x-intercepts. When we talk about a discriminant, I've hinted towards that already. B squared minus 4ac is the discriminant, and that is found underneath the square root. So our A term is 1, our B term is 6, and our C term is 5. If we're going to work with the discriminant, that is just the B squared minus 4ac. So we have 6 squared minus 4 times 1 times 5, 36 minus 20, which is 16. Our discriminant is 16. If we look back at the notes that talked about what happens if the discriminant is greater than 0, 16 is bigger than 0, of course, we get two real solutions. The graph is going to cross in two spots. We don't know what those spots are. We're not calculating that. We're just trying to figure out what type of solutions do we have. Two real solutions. We don't know what they are, but they are two real solutions. How do we know that? Because the discriminant was a positive value. The A value is 1, the B value is 6, the C value is 9. So we're looking at B squared minus 4AC. 36 minus 4 times 1 times 9. We get a discriminant of 0. And the discriminant of 0 states that you'll have one real solution. The graph is crossing at one spot on the x-axis. It's touching at only one location, one x-intercept. And that's going to happen every time the discriminant is 0. Now we don't know where it crosses for this problem. We didn't calculate that. We just calculated the discriminant, which told us it was 0. And that'll tell us that we have one real solution. Here we have an A value of 1, a B value of 6, and a C value of 13. So our discriminant is B squared minus 4AC. 6 squared minus 4 times 1 times 13. 36 minus 52. That comes out to be a negative 16. That's a negative number inside the square root. So again, if we look on the flip side, that's telling us that if our B squared minus 4AC is less than 0, that means negative, we get two imaginary solutions. That means the parabola does not touch the x-axis. There are no x-intercepts. So we have two imaginary solutions. Our last example here. Here's the formula for when we drop an object. Here's the formula when you launch it or throw it or kick it or hit it. That's this formula. So V of O is the new variable. It's the initial velocity. H of O, just like it was before, is considered the initial height. So we read our problem where a juggler tosses a ball up in the air. The ball leaves the juggler's hand 4 feet above the ground. And has an initial velocity of 40 feet per second. The juggler catches the ball when it falls back to a height of 3 feet. So we want to know how long does it take to come to 3 feet if the gravity is -16 times squared plus our velocity times t at a height of 4. It left our hand at 4 feet. We want to know when it gets back down to 3 feet. How long is that ball in the air? Well, the first thing we're going to do is bring it over and make it equal to 0. Now you could make this 16 positive if you wanted. You could bring it all to the left. That would totally work. But with the quadratic formula, it's not always as required. We did change that one problem. So 16, b is going to be 40, and c is going to be 1. So to calculate -b plus or minus the square root of b squared, no need for parentheses if you're positive, minus 4ac all over 2a. So that's -40 plus or minus the square root of 1600 plus 64 all over 2 times a. And I could have plugged it in there, I guess, but we'll plug it in now. So t equals -40 plus or minus 1664. Now 1664, square root of 1664 is 4079. So we're going to have -40 plus 40.79 over -32. And we're going to have -40 minus 40.79 over -32. A lot of times we get confused and we think the negative term is the one we don't want. Watch what happens here. We're going to take our -40 and we're going to add our answer. Our previous answer was that long decimal, or that was the square root. Here we could even do that. -40 plus the square root of 1664. That's the real answer. So we figure out what that is, divided by -32, and that gives us approximately -0.02. Now that's a negative time. We're not interested in negative time. That's really close to 0, but we're not interested in that. We're interested in -40 minus the square root of 1664. You could do 40.79. It's not going to change the answer because that's very close to the real answer. But we can be as accurate as possible. All right, divided by -32, and that gives us approximately 2.5. That's a 4, so that stays a 2. That's how long it takes. You want to label your terms with units. 2.52 seconds. So this one is the one that we eliminate as a possible answer because we're not going to have negative time. we're just going to have 2.52. Good luck.